Yesterday, the video, I did show you another graphing example, but then we moved on. We moved on and talked about how to solve this system without graphing it. So I did graph it yesterday, but then we talked about, okay, what do you do to solve it if you don't graph it? It's actually a little bit even easier, especially when it's set up like this. And yesterday we talked about how, well, this is a method called substitution. And you were given a whole worksheet yesterday, and you didn't have to graph. You just had to set these things equal to each other, solve for x, plug it back in to solve for y. As in, because this says y equals, anywhere we see a y down here, we can put what I just highlighted in red in for y, because it says y equals. So if I rewrite my second one like this, what I'm saying is this says y equals. So everywhere I see a y, I can replace it with 3 over 4 x plus 1. And this does two things for us. It allows us to solve for one of our variables. Because before, these were two separate equations. We had two variables. We can't really solve until we get it down to one variable by setting them equal to each other. And this is called equal values method. For those of you who had me last year, ultimately, this is just a version of substitution, which we will finish learning about today. But we can solve this. And with fractions, it's never fun. But if you multiply everything times 4, that gets rid of the fractions, but just make sure you multiply everything times 4. And you have an equation you can solve. I'm not going to finish it because it's in the video from yesterday. It seems like it would be a little bit of a waste of time. But that's what I wanted you to do on the worksheet yesterday for all of them. I think your worksheet looked something like... should have looked something like this. You do that for every one of them. Set these equal to each other right here. So you'd put x plus 2 equal to 4x plus 23. Subtract the x, you get 3x. Subtract the 23, you get negative 21. You get negative 7, I believe is your x. And then you plug it back in. I would plug it back into the first one. This one, negative 7 plus 2 is negative 5. You got your answer. So you do not need to graph in order to solve these. Now, not all systems are going to look nice like this, where it's y equals. And like this one. Now, yesterday I showed you could rearrange this, and we rearranged it yesterday to look like this. And then again, you could solve it using equal values. But we're actually going to go back to this example, and I'm going to show you. Here's the deal. If your equations are set up like this, it's easy, super easy. You set them equal to each other, you go from there. But this also is not so bad, and you don't have to rearrange. You don't have to do this. And I'm going to show you how to deal with that, all right? So from now on, the substitution, we don't really have to rearrange. Here's what we're looking for. We're looking for at least one variable to be by itself. So like for this one, and by itself, I mean like this, y equals, all by itself on one side of the equation. Now, luckily, both of these had that. And like I said, when we have that, you take the x parts, you set them equal to each other. Typically, you don't have fractions. You solve from there. Solve for x, plug it back in to solve for y. All right? Now, let's take a look at this example. This is a very short example, but look, this is not solved for y. You can see the y there. It says 2y plus x. It's all on the same side, both the x and the y. So we don't have something nice with y equals. But what we do have is we do have a y equals here. And you only need one, because watch this. It says y equals 4. So anywhere in the second equation you see a y, that's why this method's called substitution. You will substitute or replace it with 4. Now we can solve. 8. There's only one variable, so we can actually solve. 2 times 4 is 8, minus 8. X equals negative 5. Now, in this case, you don't have to solve for y. I'll show you what I mean on the next slide, but you don't have to solve for y because we have it. Y is right here, y equals 4. So the answer there is negative 5, 4. If we were to graph these two lines, they would meet at negative 5, 4. Okay, let's take a look at a more complicated example. As in the first one, the one we did yesterday. Now, from yesterday, you'd have to rearrange this and get y by itself, and then we could set them equal to each other. But based on what we just did here, where you have one variable ready to go, solve for y, we can do the same thing here. This says y equals, here's my y by itself, y equals 5 plus x. So what we can do is, anywhere you see in this equation, the other equation, so whatever equation you have solved for y, I have it in red, you go to the other one. And anywhere you see a y in that equation, you're going to replace it with, and hopefully I can, nope. Let me see what I can do here. Anywhere you see a y, I'm just going to kind of hang it out here, you can replace it with that 5 plus x. You can take it and just replace it with 5 plus x. Take that away. That was kind of cool. I didn't mean to do that. And put in 5 plus x. There you go. Now we have something we can solve. We have an x here. We have an x here. We're good to go. Distribute. So let's see here. 2x plus 10 plus 2x equals 10. Put my two x's together. They're on the same side, so I just combine my like terms. The only time that you... Let's see if I can... There we go. The only time that you do the opposite is when they're on opposite sides. So x is 0. I'm going pretty fast. Feel free to pause. But by substituting that 5 plus x into the other equation, everything's in one variable, we find x equals 0. Then we need to plug this back in and solve for y. We want to find the point where these two things meet. And I think it's x plus 5, right? Or 5 plus x, same thing. I'd pick that one to plug into. That seems pretty easy. You plug in x, which we found to be 0. And what do you know? That's not so bad at all. Y equals 5. So what that means is these 2 points, and we found this yesterday, meet at the point 0, 5. So another way to solve that problem. We graphed it yesterday. We used equal values, which again is just a version of substitution to solve it. And again, we found the same answer. This time using straight up substitution. Okay? And all because of this right here. All because of this right here. Y equals, that allows us to plug in whatever's on the other side in for y, and we can solve from there. All right, let's take a look at one more example here. Because sometimes, this is the last one, no, let's go with this one. Sometimes, none of the equations are solved for a variable. You can see right here, the y and the x are on the same side of the equal sign, right here. How about this one? The x and y are on the same side. Now, we'll talk about another method later that might make this easier, but what else do you notice? It's not going to be hard to get a variable by itself. Look, y it doesn't have a number or a coefficient. That's a number in front of a variable. It doesn't have a number there. So what if we just rearrange? So sometimes you'll have to do a little rearranging, but subtract 4x over to the other side. Basically, get y by itself. So a little rearranging might be necessary. And I'm going to actually kind of scribble this one out then. This one right here, because we rearranged it. We took the 4x and we just moved it to the other side. 4x, moved it to the other side. But now we have something rearranged that has a y all by itself. And by the way, it doesn't always have to be y. It could be x. We could have solved for x here. The only thing that made me a little nervous was the negative. That we would have had to deal with that. So just be aware. It doesn't always have to be y. It just so happens that every one of ours has. But there you go. Now go from there. That the one we rearranged is solve for y. So take the other equation, and anywhere you see a y, and I'm seeing it right here, I'm going to replace it with, I'm going to do a little bit of erasing here so I have room, replace it with this right here. Negative 4x minus 3. I fit it in there good. Distribute. 6 only distributes to what's in parentheses. 6 times 4 is 24. 6 times 3 is 18. Combine your like terms. So the x's go together on that side. Add 18. And I believe we end up with negative 1. 7 plus 18 is 25. We want to get x by itself. Divide by negative 25. X equals negative 1. There you go. So all it took was a little bit of rearranging, but then we have an example like the one we just did. Plug that in for y. So, and we're down to 2 terms that have an x. They combine, so we just have x left. We find negative 1. Go ahead and plug that negative 1 in for one of your equations to find the y. I'll go with this one. Y equals negative. You can use ones that I was wondering what was going on there. That was just weird. My line tool was actually working there for a second. Anyway, negative 4x. What was it? Minus 3. Minus 3. Plug in negative 1 for x. Looks like you end up with 1. So the point, if you stop here, as long as you circle your answers, you're good. But if you put negative 1, 1, that's your x, that's your y. You found where they meet. Okay? But you got to find both variables. So that's substitution method. All right? Like I said, you're not always going to need to solve for y. I was looking for an example. I don't think there is one. But you can see right here, this is solved for x. So wherever you see an x in the second one, you would replace it with negative 2y minus 1. And then the same process would ensue. All right. Other than that, folks, feel free to go back, follow these examples while you work on big ideas. Have a good day.